For point 4, we're going to be factoring polynomials. So a lot of the techniques that we are going to talk about in this section, we've already done before the last time we did factoring, but we're also going to talk about a couple different techniques too. So previously you factored quadratic polynomials. You can also factor polynomials with degree greater than 2. Some of these polynomials can be factored completely using techniques we have previously learned, but then we're also going to be learning a couple new techniques. When it says factor completely, some things may have to be factored more than once. So just keep that in mind. So example 1, it says factor each polynomial completely. Looking at A, what could we do to factor? Take out an x. Take out our GCF, which is an x. So I'm going to take out an x. And then I'm left with x squared minus 4x minus 5. Can we factor this anymore? We wouldn't want to because our x squared is positive. So like we always want the leading term to be positive. Ronnie.
When you do the greatest common factor, or you have to do something at times 5. It's the 4, right?
Yes, we need two factors of negative 5 that add to negative 4. What are two factors of negative 5 and positive 1? Perfect. So that factors into x minus 5 and x plus 1. And then we can't forget about the x that we took out in the beginning. So this would be factored completely. All right, let's look at B. What can we do to factor here? Awesome. Take out a y to the third power. What else? A 3. So we can divide both of them by 3, and also we have a y to the third power in common that we can take out. So take out our GCF. What are we left with when we take out 3y to the third power? Y squared minus 16. Can I factor y squared minus 16 anymore? What's special about y squared and 16? Difference of squares. They are perfect squares. So this is the difference of squares. How do we factor the difference of squares? We find the square root, so that would be y and 4. And then what do they go into? What would our factors of this be? Awesome. Difference of squares factors into a parentheses with a plus and a parentheses with a minus. So it'd be y plus 4 and y minus 4. And this would be as factored as we can go. All right, what can we do with C? Awesome. We can take out a 5z squared. That's our GCF. When we take out a 5z squared, what are we left with? Because we took out the z squared, so it'd just be plus 9. So we take out the 5z squared. When we divide everything by 5z squared, we get z squared plus 6z plus 9. Now we can factor this normally. What are two factors of 9 that add to 6? 3 and 3. So we have z plus 3 and z plus 3. And don't forget about our GCF that we took out in the beginning. So 5z squared times z plus 3 times z plus 3. Or you could say z plus 3 squared because we have two of them. All right, let's practice some more. Number 1 on the next page. What should we do first? Take out an x. We're left with x squared minus 7x plus 10. What are two factors of 10 that add to negative 7? Negative 5 and negative 2. Perfect. So what would this factor into? Awesome. And don't forget about the GCF that we took out in the beginning. X times x minus 5 times x minus 2. Let's look at 2. What should we do first for number 2? 3n5, perfect. We're going to take out a 3n to the 5th power. When we divide out a 3n to the 5th power, what are we left with? Minus 25, perfect. N squared minus 25. What's special about n squared and 25? It's the difference of squares. What does the difference of squares factor into?
Minus 25 n plus 5 n plus.
Awesome. One parentheses with a plus and one with a minus. So this would be n plus 5 and n minus 5. And don't forget about the GCF that we took out in the beginning. Let's look at 3. What should we do first for 3? Take out 8m cubed. What are we left with? Just 8m squared minus 2m plus 1. Because we took out an 8m cubed, so 8m to the 3rd power divided by 8m to the 3rd power would be 1. Don't forget about that 1 there. If we were to have distributed the 8m cubed back out, you'd want the same thing as the original. So don't forget about the 1 there. What are two factors of 1 that add to negative 2? Negative 1 and negative 1. So this would factor into m minus 1 and m minus 1 with the 8m cubed out front. Good with this one? All right. Next, we're going to talk about another special type of factoring. So similar to the difference of squares, we have the sum of cubes and the difference of cubes. So our formula for cubes are different for the sum and the difference, but the variable parts are the same. It's just the signs that change. So if I have the sum of cubes, a perfect cubed plus another perfect cubed, this would factor into a plus b times a squared minus a times b plus b squared. Now, one little trick to remember the difference of the signs in the sum of cubes and the difference of cubes is SOAP. It stands for same sign, it's up there, opposite sign, and then the last one is always positive. So if we're adding, it's the same sign, the opposite sign, and then always positive. Same with the difference of two cubes. If we're subtracting, we have the same sign, the opposite sign, and the last one is always positive. So SOAP stands for same, opposite, always positive. So it's just a little trick to remember the signs. Yes, you need to remember these formulas. So let's look at example 2. So for A, we have the difference of cubes. Difference of cubes, our formula would be A minus B times A squared plus AB plus B squared. Because when it's a minus, our signs go same, opposite, always positive. So same sign, opposite sign, always positive. Now if A to the 3rd power is X to the 3rd power, what is just A? X, perfect. And if B to the 3rd power is 125, what is just B? What to the 3rd power gives us 125? 5. So some common cubes, I'll write those on the side over here because we'll see them again and again. So 1 to the 3rd power would be 1. 2 to the 3rd power is 8. 3 to the 3rd power is 27. 4 to the 3rd power is 64. 5 to the third power is 125. And 6 to the third power is 216. These are pretty common ones that you'll see. I think 7 to the third power might also come up too, which is 343. So these are just helpful to know. If you have like x to the third power plus 8, it's helpful to identify that that 8 is a perfect cube, so you're going to use your sum of cubes formula. So just like here, we see 125. 125 is a perfect cube, so we know we're going to use our difference of cubes formula. So let's plug in. X is going to go into all of the A spots, and 5 is going to go into all of the B spots. So we have x minus 5 times x squared plus, how do I say x times 5? 5x plus 5 squared. And what is 5 squared? 25. Because 5 to the third power is 125. So we had to think what cubed gives us 125, so that would be 5. So this would be our answer, and this is as factored as we can go. We can't factor anymore. So let's look at B. Well, looking at B, these aren't the sum of cubes because s squared isn't a perfect cube. So what do you think I could do first? 16 and 54 also aren't perfect cubes. What should I do first? Factor how? Take out the GCF. What is our GCF with the numbers? 16 and 54. Can I divide 54 by 4? Can I divide 54 by 8? Think smaller. 2. So we can take out a 2. And how many s's can I take out? 2. So 2s squared. So now I divide out a 2s squared. I'm left with 8s to the third power plus, what's 54 divided by 2? 27. And then the s goes away. So now is 8s cubed and 27 perfect cubes? Yes. So we're going to use our sum of cubes formula. So our sum of cubes is a plus b times a squared, ab, and b squared. What are the signs going to be? So the first one's the same sign. What's the next one? Opposite. The opposite. And what's the last one? Positive. Always positive. So now, we're only looking at this part. That 2s is just going to stay on the outside. 2s squared. So if a to the third power is 8s to the third power, what is just a? What cubed gives us 8? 2. And what cubed gives us s cubed? 3. I mean, not 3. S. S to the third power would be s to the third power. And then with 27, if 27 is b cubed, what is just b? 3. Perfect. 3 to the third power would be 27. Bless you. So let's plug in. In all of our a's, we're going to put 2s. So I'm going to put a 2s in all of the a's. And then in all of the b's, we're going to put 3. So we have 2s plus 3. Can't simplify that anymore. But what is 2s squared?
4s squared.
Awesome. 4s squared. 2 squared would be 4, and s squared is s squared. Minus, what is 2s times 3? 6s. Perfect. So minus 6s. And then plus, what's 3 squared? 9. And then we can't forget about our GCF that we took out from the start. So 2s squared times 2s plus 3 times 4s squared minus 6s plus 9. Next, we're going to factor by grouping. Does anybody remember how we factored by grouping before? Whenever we have 4 terms, you always want to try to factor by grouping. So when we factor by grouping, we group the first 2, group the second 2, and take the GCF out of each group. And our GCFs go together in one group. What gets left behind goes together in the other group. So let's look at example 3. We have 4 terms, so we're going to have to factor by grouping. Group the first 2, group the second 2. What's our GCF in the first group? Z squared. So I'm going to take out a z squared. When I take out a z squared, what are we left with? Z plus 5. What's our GCF in the second group? Why do we do a -4, not just 4? We want the inside to be positive. We need the inside to be exactly the same as our other inside part in order to factor by grouping. So I'm going to take out a -4, and I'm left with z plus 5. So now the 2 outside parts go together. So we have z squared minus 4, and then the 2 inside parts go together. Z plus 5. What's one way that I could check to see if I did this right? You could always FOIL it back out. Now, can this be factored anymore?
Yeah.
How? The difference of squares. Z squared minus 4 is the difference of squares. So what would z squared minus 4 factor into? Z plus 2 and z minus 2. So we have a z plus 2, z minus 2, and z plus 5. Perfect. Any questions here? So let's look at number 4. So what's special about a to the third power and 27? Perfect cubes. So I'm going to use my perfect cube formula. What is my sum of cubes formula? A plus b times
A squared minus AB plus B squared.
Awesome. Good job. So now let's figure out what a and b are. So if a to the third power is a to the third power, what's just a? A. Awesome. If b to the third power is 27, what is just b? 3. Perfect, because 3 to the third power would be 27. So we're going to plug in a into all of the a's, so it's going to stay the same, the a parts. And then 3 goes into all of the b's. So we're going to plug in 3 into all of the b's. So I have a plus 3 times a squared minus what? 3a plus 9. Perfect. Don't forget to square whatever you're squaring. If you have a number and a variable, both of them get squared. Any questions here?
How do you know what to use that formula?
If they're perfect cubes, you want to use the formula. All right, let's do 5. So 5, it's 2 terms, so we should be thinking either difference of squares or sum of cubes or difference of cubes. But these aren't perfect squares and they aren't perfect cubes. So what can we do first? Take out the GCF. What is our GCF? Z squared. Z squared, but do we have any numbers in common too? Can I divide 750 by 6? Let's try. I think so. 6 goes into 7 one time with 1 left over. 6 goes into 15 two times with 3 left over, and 6 goes into 35. Perfect. So we can take out a 6 z squared. When we take out 6 z squared, we are left with z to the third power minus 125. What's special about z to the third power and 125? Difference of cubes. So my difference of cubes formula is what? Not a plus b, a minus b. Remember, it's the same sign that you start with. Same, opposite, always positive. Soap. What would come next? A squared plus ab plus b squared. So if a to the third power is z to the third power, what is just a? Z. If b to the third power is 125, what is just b? 5. Perfect. So I'm going to plug in z into all of the a spots and 5 into all of the b spots. So I have z, z, and z, and then 5 goes into all the b spots. 5, 5, and 5. Let's simplify this a little bit. So we have 6z squared that we took out from the beginning. Don't forget, if you take out a GCF, you need that in your answer. Z minus 5 times z squared plus what? 5z plus 25. Awesome. That would be our answer. And what's one way that we can check to see if we did it right? Foil it out. You can foil these 3 things together. You'll end up with the original. All right, and then let's look at 6. When we have 4 terms, how do I factor? Grouping. Group the first 2, group the second 2. What's our GCF in the first group? X squared. When we take out an x squared, we are left with x plus 4. What's our GCF in the second group? -1. Awesome. When we take out -1, what are we left with? X plus 4. So the 2 outsides are going to go together. We have x squared minus 1. Then the 2 insides go together. X plus 4. Can this be factored anymore? How? We have the difference of squares. X squared and 1 are perfect squares. So what does x squared minus 1 factor into? X plus 1 and x minus 1. And then we have an x plus 4. Perfect. Any questions here? Good with this one? All right, let's look at 7. What do I do when I have 4 terms? How do I factor? Grouping. Group the first 2, group the second 2. What's the GCF from our first group? Y squared. What am I left with when I take out a y squared? 3y plus 1. Perfect. That y squared doesn't just disappear. Y squared divided by y squared is 1. So you need the 1 there. What's the GCF in the second group? 3. So when I take out a 3, what am I left with? 3y plus 1. So I'm going to group the outsides together. We have y squared plus 3. And then the insides are going to go together as 3y plus 1. Can I factor this anymore? Nope. What if I had y squared plus 4? Could I factor that anymore? Is y squared plus 4 the difference of squares? What does difference mean? Subtract. Is there a subtract here? No. Y squared plus 4 can't be factored anymore. This would be it. But if I had y squared minus 4, what would this factor into? Y plus 2, y minus 2. Awesome. So just make sure you know the difference. It has to be the difference of squares in order for it to factor more. If you have the sum of perfect squares, it cannot be factored more, unless you had a GCF that you could take out. So just make sure you know the difference between the two.